Welcome to this video on special products. Let's begin. There are two types of special products we will cover in this section. They are difference of squares and perfect square trinomials. Let's begin with different squares. In factored form, a difference of squares looks like a plus b times the quantity a minus b. Notice that there are opposite signs in the two sets of parentheses. If we were to expand or distribute or multiply a plus b times the quantity a minus b, we will get a squared minus b squared. Notice in the expanded form we have two terms, 1, 2, that are joined by a subtraction sign. Also, notice that both a squared and b squared are perfect squares. So that is a summary of difference of squares, or difference of two squares. Let's now turn our attention to a perfect square trinomial. In factored form, this is going to look like a plus b times itself, or you could write this even more simply by writing it as a plus b quantity squared. Notice that instead of having opposite signs, this time we have the same signs. In expanded form, in other words, if we were to expand or multiply this, we would end up with a squared plus 2ab plus b squared. Notice, unlike in difference of squares where we ended up with only two terms, in a perfect square trinomial, tri meaning 3, we have 1, 2, 3 terms. So let's do a few examples and get more comfortable with these two types of special products. So you can see in your notes that we have this table where we're comparing difference of squares with perfect square trinomials. So let's start with the first example, a plus b times a minus b. So again, we're already being told that this is a difference of two squares. However, if we were not told this, right, we would still know and be able to recognize the difference of squares because we have these opposite signs. Also, if you get to a problem and you're not sure what to do, usually the directions are either going to ask you to simplify or expand. Either way, what we want to do is we want to actually multiply a plus b times the quantity a minus b. So, in a previous video, we learned how to do that. Again, of course, you can always use FOIL if you would like, but the preferred method that I'm going to use is the distribution method. So I'm going to rewrite this as a times the quantity a minus b plus b times the quantity a minus b, and then I'm going to distribute. So remember, a times a, we use the product rule, we add the exponents, that's going to give me a squared. A times negative b is negative ab. Remember that guideline or rule that we put all of our variables in alphabetical order. So when we get over here, right, you might think you should write ba, but we're going to rearrange those and we're going to rewrite them in alphabetical order. So we're going to write it as ab. Okay, and then we have b times negative b, which is negative b squared, again applying the product rule and adding those two exponents. So remember, the reason that we care about order when we write our variables is that it makes it easier for our human brains to recognize and identify like terms, right? So in other words, if I had written this as BA, right, I might not realize that these two things are like terms. However, if I write it as AB, then it's easier for me to see that the inner terms do combine. So negative 1 plus 1 is just 0, so we end up with a squared minus b squared. You might notice in this example I have just proven to you that the factored form of difference of squares is a plus b times a minus b, and that the expanded form is a squared minus b squared. So this first example is a demonstration of the definition of difference of squares. Okay, so let's turn our attention to a perfect square trinomial. So here you can see we have a plus b quantity squared. So a very, very common thing that I see is that people want to rewrite this as a squared plus b squared. Okay, and just please make yourself a note, this is absolutely not true. Okay, one technique for helping yourself remember if you think it might be true, right? One thing that you can do is just actually stick numbers in there. So let's let A and B both be 1, and then let's see if this is true, right? So if a and b are both 1, then I'd have 1 plus 1 quantity squared. Well, that's 2 squared or 4. Okay, but then if that's equal to a squared plus b squared, then that would be equal to 1 squared plus 1 squared, which is 1 plus 1, which is equal to 2. Okay, 4 and 2 are clearly not the same. So again, by picking some values of a and b, we can see that this is just not true. Okay, so you might remember, right, if I have x squared, I can rewrite that as x times x, right, x times itself. Or if I have 3 squared, I can rewrite that as 3 times itself. So that means that when I have a binomial a plus b quantity squared, right, I can rewrite that as a plus b times itself, or a plus b times a plus b. And now, hopefully, you recognize and realize that we have to either use FOIL or we have to use our distribution process. So I'm going to use distribution. So we have a times the quantity a plus b times the quantity a plus b. So we're going to get a squared plus ab plus, again it would be ba, but we're going to rearrange it. So it's ab plus b squared. Okay? So notice that unlike with a difference of squares, with a perfect square trinomial, our inner terms do not cancel out, but they actually add together. So 1ab plus 1ab is 2ab. So we have we have a squared plus 2ab plus b squared. So again, you might realize or notice that this is actually the definition of a perfect square trinomial. So we have proven that the factored form looks like this and the expanded form looks like that. Okay. So hopefully, when you see them side by side, you can see some of the differences, right? We can see that when we expand or multiply a difference of squares, we get 2 terms. We can see that when we expand a perfect square trinomial, we get 3 terms. So again, the magic, if you will, of the difference of squares is that the inner terms cancel out because of these opposite signs, right? The plus and the minus, everything's the same except for the signs, so that's why these inner terms cancel out. Conversely, right, in the perfect square trinomial, you have accumulation because you have 2 of the same sign, and therefore nothing cancels out. So that's why you still have that middle term. All right, let's do some more examples. So again, remember, a good idea is to pause the video, work through examples when you feel confident and ready, and then unpause the video and see if you are correct. Okay, so here we have x plus 5 times the quantity x minus 5. Again, I'm going to rewrite this using my distribution method. So this becomes x squared minus 5x plus 5x minus 25. Again, those inner terms cancel out, so we get x squared minus 25. Okay, so remember, difference of squares, the definition is baked into the name, right? Difference means what? It means subtraction. Well, we are absolutely subtracting those 2 values, and the values that we're subtracting are both perfect squares, right? X squared is a perfect square. It's x times itself. 25 is a perfect square. It's 5 times 5. So x squared minus 25 is a difference of squares. Okay, in the next example, we have x minus 5 quantity squared. Again, please, please, please be careful. It is not equal to x squared minus 5 squared. Okay, if you write that, it's just absolutely wrong. No partial credit. Okay, instead what we have to do is we have to write this as x minus 5 times itself, and then we can use the distribution method here. So this is going to be x squared minus 5x plus 25. Okay, and this time, remember, instead of canceling out, those inner terms are going to accumulate. Minus 5 is minus 10. So we have x squared minus 10x plus 25. Okay. So again, on the left side, we have a difference of 2 squares because we have a binomial, x squared minus 25. On the right-hand side, we have a trinomial, x squared minus 10x plus 25. Okay, let's do some more examples. So in example 3, we have 3x plus 7y times the quantity 3x minus 7y. Again, I'm going to employ the distribution, oops, I forgot my x here, the distribution method. Okay, you can definitely use FOIL or any other valid method that you choose. Okay, so we get 9x squared minus 21xy plus 21xy, again rewriting those variables in alphabetical order, okay, minus 49y squared. Okay, again, remember the magic, if you will, of difference of squares is that those inner terms are going to cancel themselves out, cancel each other out. So we have 9x squared minus 49y squared. That's our final answer. Okay, turning our attention to a perfect square trinomial. Again, remember this is not 3x quantity squared plus 7y quantity squared. Instead, we have to rewrite it as 3x plus 7y times itself. Okay, so then I'm going to, again, use the distribution method and write it like this. Okay, so that's going to give me 9x squared plus 21xy plus 21xy plus 49x squared. I sort of ran out of room here, but the final answer should be 9x squared plus 42xy plus 49. Uh-oh, I think I wrote that wrong. Sorry about that, guys. This should be 49y squared. 49y squared. Okay, so again, if we look at our final answer on the right-hand side, we can see that there are three terms, 9x squared plus 42xy plus 49y squared. And on the left side, we can see that there are only two terms, right? And again, the reason there's only two terms is that these inner terms cancel out. The inner terms cancel out because we have opposite signs to begin with. Okay, so let's do one more example. So again, we're going to expand. So we have 2x times the quantity 2x plus 6y minus 6y times the quantity 2x plus 6y. So this gives us 4x squared plus 12xy minus 12xy minus 36y squared. Okay, again, these inner terms are going to cancel out because they have the same value and opposite signs. So our final answer is 4x squared minus 36y squared. Okay, so I'm going to erase this here because I want my room back. Okay, for my perfect square trinomial, again, remember you cannot write it as 2x quantity squared minus 6y quantity squared, right? Instead, what we have to do is we have to write 2x minus 6y times itself. Okay, and then we can use the distribution method here. So we have 2x times the quantity 2x minus 6y minus 6y times the quantity 2x minus 6y. Okay, so that's going to give us 4x squared minus 12xy minus 12xy plus 36y squared. Okay, so our final answer is going to be 4x squared minus 24xy plus 36y squared. Okay, again, notice with our difference of squares, these opposite signs mean that the inner terms cancel out, so we're left with a binomial. Both, right, and both terms, 4x squared and 36y squared, are both perfect squares, and they're separated by a subtraction, right, meaning that is a difference of squares. Conversely, with our perfect square trinomial, we end up with three terms because we have the same sign, and so the inner terms accumulate.